Welcome to Security Plus. This is Chapter 14, PKI and Encryption Protocols. Last week in class we went through Chapter 13. We talked pretty extensively about what encryption is and how it's used. So this chapter is a little bit more about implementation of the public key infrastructure and some different protocols that are used with security. So that's what this is going to focus on. So the first part of that is the public key infrastructure. So when you see public key, think asymmetric. So we talked about symmetric versus asymmetric encryption. Symmetric is when you have the same key or a related key on both sides, and asymmetric is when you have something different. And we talked about the issue, if you have two different keys, how are you supposed to transmit them in a way that is safe so that communication can take place. And the way that we do that is through PKI, the public key infrastructure. So this is a system of hardware, software, policies, procedures, and people that make the transmission of the keys and the management of the keys happen. So we create, distribute keys, manage them, store them. We revoke digital certificates as well. We'll talk about those. We're going to secure our e-commerce sessions with the PKI, email transmissions, connections to remote computers through RDP, remote networks. This includes the people who use it, the computers that it's on, servers, services, and encryption is in the forefront. So when we obtain a certificate through a web browser during an encrypted session with an e-commerce website to purchase something, we are using the public key infrastructure. A lot of times it happens in our browser behind the scenes and we don't know it's there, so this chapter seeks to kind of make you aware of that. Private key usage, if you're sending an email and you're encrypting it with a digital signature, and we'll talk more about digital signatures as well, all of those things are part of the public key infrastructure. So here's an example of kind of what those things look like. So Bob over on the left is going to create and send a message that says buy stock now. He's got a public key attached to that. Mallory's going to intercept the message and create an imposter key, which is going to end up sending a different message. Alice is going to receive it. She's going to see that now it says to sell stock, but she's going to look at the public key and know that it's different from Bob's public key, so she knows that the message has been compromised. So that's like a classic man-in-the-middle attack. If I go to open an account at a bank, they want to verify that I am who I say I am. They ask me for some sort of third-party verification, and it's probably going to be a driver's license. So the DMV is a trusted third party that identifies me as who I told them I was, and then I get to open my bank account. They can check the photo, they can match, and that is essentially what PKI is. So that's the entire system that allows me to open the bank account. A digital certificate is used to associate a user's identity to a public key that has been digitally signed or trusted by a third party, like in that example the DMV would be. So the third party verifies that the owner and the public key belongs to the owner, and that everything meshes well together. If we have an imposter public key, we know that something was compromised along the way. A certificate authority is that trusted third-party agency that's responsible for issuing those certificates, negotiating the security of a connection. And oftentimes when you see this in a browser, you see a secure connection shows as being green in some way or having a lock on it. And here's a little bit about the different browsers. And you can see a lot DigiCert here. That's one of the big names that comes to mind when you think about a certificate authority. So they are a trusted third-party agency. VeriSign is another instance of that. So certificates are based on this standard. The standard is called the X.509 standard. So what that includes is the information about the owner and their public key. Remember, a public key is public so that anyone can access it. The private key is what we keep secret. It also contains the information about the certificate, like the name, the digital signature, the serial number, when it was issued, when it expires, and the version number. All of those things come from the certificate authority. A registration authority is used to verify requests for certificates. If you have a whole bunch of certificate authorities in your organization, you might need a registration authority, or that might just come straight from the CA. The registration authority tells the certificate authority to go ahead and issue a certificate. The certificate revocation list is a list of all the certificates that are no longer valid because they've been revoked by the issuer for some reason, which is normally because there's been some sort of security breach. There's been theft. Um, they've figured out that the key has been compromised in some way, so they'll revoke that so it's no longer showing up in that green in the address bar and showing you that it's a good ticket, or a good certificate. The online certificate status protocol doesn't have as much information as the revocation list does, and it doesn't have encryption with it. So basically, it's like a short and sweet way to go and look. Is a certificate good or bad? And that's it. It doesn't give you information why or when it was bad. It's just kind of a quick and dirty list. Not a lot of information there. Key escrow is a secure copy of the user's private key. Remember, private keys are meant to be kept secret and private. So sometimes, especially because a government organization requires it, a certificate key is going to be held in key escrow so that if the third party needed it, they needed to gain access to encrypted communications, they could do that. So a business may need to access information that an employee had encrypted on their hard drive, on their laptop. That employee is no longer with the organization. You need to be able to get back into that laptop in some way so that you can access the communications the employee used while they were with the business. So key escrow is when that would come into play. And again, a lot of times key escrow comes into play because it is governmentally regulated or required for some reason. A little more information about certificates. We've got a single-sided certificate. The server validates itself to the recipients, so like the users accessing the website are validated. A dual-sided certificate is the server and the user validate their identities, obviously a little bit more secure. If you don't have that many computers or that many sessions involved, a dual-sided certificate is easy. The web of trust is this decentralized trust model. So the problem with having some sort of certificate authority is what happens if that certificate authority gets compromised. Then people have access to private keys and things that they should not have. The web of trust model is the answer to that. So it's like a peer-to-peer model, and the classic example used by that is PGP. So with PGP or pretty good privacy, which is sometimes used in email, it's a web of trust model that everybody has a piece of the key, and everybody that has a piece trusts each other. So that is another answer to having a certificate authority. There's no root certificate authority. There's no VeriSign. There's no big company that controls it, but it's normally the people within an organization that each hold a piece. So now we get to the end of the chapter where we talk a little bit about protocols. And you know how I feel about protocols when it comes to exams. You need to know what it is. You need to know when it's used, and there'll always be some little differences between the protocols that I think are important when it comes to answering questions on the Security Plus. So the protocols that we're looking through in the next couple chapters really have to do with securing VPN connections. So when we spoke back in the beginning of this little lecture about remote connections and securing remote connections, these are the protocols we're talking about. So a VPN gives us a virtual private tunnel over the internet, but there's no security inside of it. These are the things that give a VPN security. These protocols encapsulate packets over a VPN so that they are encrypted traffic being sent through that tunnel. So it's no good to just have a private tunnel across the internet if you don't have security involved with that. Okay, so the first one is a point-to-point tunneling protocol, or PPTP. That's used in VPNs. It encapsulates PPP packets and sends encrypted traffic, and that is on port 1723. Layer 2 tunneling protocol, as you could guess, is a data link layer protocol. It resides on layer 2, also used in VPNs. So it creates an unencrypted tunnel if you use it by itself, But if you use IPsec, another protocol, then it creates the encryption. So this is just for tunneling. This one is not for encapsulating those packets in a way that makes them encrypted. You have to pair it with IPsec to be able to do that. And it often uses that public key infrastructure as well. Now, IPsec, a lot of times if you're looking at job descriptions of security analysts or network administrators, they always want familiarity with IPsec. It's most widely used when it comes to authenticating and encrypting IP packets. So if you're transmitting over a network and you want security, you want the encryption to occur, you use IPsec or Internet Protocol Security. There's a Professor Messer video on that. There's a link on the Moodle page that you need to watch. So within IPsec, there are three protocols. There's SA, AH, and ESP. Here's what they do. So the secure association has to do with setting up the secure connection and the security information involved with that. So that uses either certificates or can use cryptographic keys, but it sets up the session. The authentication header gives you a header tag to be able to offer hashing and authentication within each packet. The encapsulating security payload is the part that does the actual encryption. So these three things together are part of IPsec. Now the reason that's important is because you know how the Security Plus likes to do the thing where they give you a bunch of letters and they're all answers to a question. AH and ESP pop up a lot in those general answers. So you need to understand that they have to do with IPsec and they have to do with secure communications and encryption on a network because that will help get you through test questions. So I want it to be something that you're familiar with and not something that you kind of skate past and go, well, I haven't heard of that, so it's probably the answer. So be sure to watch that video on IPsec from Professor Messer. I want to run through the Socrative questions, and I know that we can't collaborate on them in class like we normally would do. But I want to be able to, maybe if you want to pause the video, look through the answers and make your own guess and go over that with me. What two items are included in a digital certificate? Select the two best answers. A user's private key. B, certificate authority's digital signature. C, the user's public key. Or D, the certificate authority's IP address. Let's look at the answer together. Okay, so the two items included in a digital certificate are the digital signature from the certificate authority, the person that made the certificate and verified it, as well as the user's public key. So the public key, again, is something that can be seen. The secrecy of the communication is not dependent on the public key, it's dependent on the private key. That's why that's what we find in the digital certificate. Which of the following is usually used with L2TP? Is it IPsec, SSH, PHP, or SHA? And as we spoke about just a couple slides ago, with L2TP, we need to encapsulate that with IPsec. Remember, L2TP was just a tunneling protocol, but IPsec actually encrypted the packets for us. So the answer is A, IPsec. Which of the following encryption concepts is PKI based on? Asymmetric, symmetric, elliptical curve, or quantum? So we spoke about symmetric having two keys that were the same or mathematically related, whereas asymmetric would be the answer here because we are giving two different keys to different parties, and we're having to determine how we're going to do that securely. So that public key infrastructure is the asymmetric key type. Which of the following protocols creates an unencrypted tunnel? L2TP, PPTP, IPsec, or VPN? Okay, so as we spoke about earlier, a VPN is a private but unencrypted tunnel to the internet. And we need some other protocol like PPTP or IPsec to make that a private tunnel that has encryption in it as well. What should you do to make sure that a compromised PKI key cannot be used again? Renew the key, reconfigure the key, revoke the key, or create new key. So the answer for this one is going to be C, to revoke the key. So to make sure that it is never used again, you're going to completely remove the ability for it to be used again by revoking it, which should solve that problem. What should you publish a compromised certificate to? CRL, CA, PKI, or AES? Notice how they throw in, and you'll see a lot of this once you become familiar with encryption algorithms. You'll see they get thrown into questions pretty randomly, just kind of as a test. But you're going to publish a compromised certificate to a CRL, a certificate revocation list. Because it has been compromised, it has been revoked, that's where it will go. You have been asked to set up authentication through PKI and encryption of a database using a different cryptographic process to decrease latency. What encryption types should you use? I had a question fairly similar to this on the Security Plus exam that kind of threw me for a loop at first. A, public key encryption to authenticate users and public keys to encrypt the database. Public key encryption to authenticate users and private keys to encrypt the database. Private key encryption to authenticate users and private keys to encrypt the database, or private key encryption to authenticate users and public keys to encrypt the database. So very wordy question. The answer to this one is going to be B. So public key encryption to authenticate users and private keys to encrypt the database. So it says that you've been asked to set up authentication through PKI, which tells me that the authentication portion of this is going to be public key encryption, because public key encryption is how we achieve, PKI is how we achieve public key encryption. And then it says you're going to have to use something different, a different cryptographic process for the encryption of the database. So it's going to be the other one, right? You really only have two options, public key and private key. If my authentication is going to be through PKI for authentication, that means that private keys are going to have to be used to encrypt the database. Which of the following uses an asymmetric key to open a session and then establishes a symmetric key for the remainder of the session? TLS, SFTP, HTTPS, SSL, or TFTP? The answer to that one is HTTPS. Uses an asymmetric key to open the session, then establishes a symmetric key for the remainder of the session. Which of the following describes key escrows? Maintains a copy of the user's private key for the purpose of recovering the CRL. Maintains a secured copy of the user's private key for the purpose of recovering the key if it's lost. Maintains a secured copy of the user's private key for the purpose of recovering a message if the key is lost. Maintains a secured copy of the user's public key for the purpose of increasing network performance. Okay, the answer is B. So we're maintaining a secured copy of the user's private key, the one that's supposed to be kept private, for the purpose of recovering the key if for some reason the key is lost. Last question. When a user's web browser communicates with a CA, what PKI element does the CA require from the browser? A public key, a private key, symmetric key, and a secret key. When a certificate authority is communicating with a web browser, it wants the web browser's public key so that it can authenticate between the two. So the answer to that one is a public key. Be sure in this chapter to watch the Professor Messer videos on Moodle. They do help to make a lot more sense as far as the certificate authorities, the PKI, and how all this stuff fits together. This chapter is a little more difficult to me because it's something that we've just we know happens in the background, but we really haven't explored why or how or what those things mean. But your labs that coincide with this chapter should help with that as well. All right, let's get into chapter 15, redundancy and disaster recovery. If you've been through Network Plus, most of this is going to sound really familiar. And to be honest, a lot of it has to do with just kind of common sense approaches to controlling a network and controlling security on a network. So this chapter talks a lot about redundancy planning and all the different ways you can be redundant and fault tolerant in a network, as well as disaster recovery planning and procedures, how you're backing up your data when a disaster happens, how are you going to address it. So first off, redundancy planning, it all starts with the single point of failure. This is one object or one part of a system. If it fails, the entire system fails. So for a lot of people, that's the ISP. If our internet service provider goes down, then we can't access Moodle. At TSTC, we can't access our email or Google or anything. Now, of course, we can go off-site and do that, but it does kind of leave the campus at a standstill until that becomes ready again. So the way that we eliminate the single point of failure is by using redundancy. So this is going to keep downtime to very little or nothing at all. So in a network setup, downtime is our absolute enemy, and we want to avoid it at all times. While a system is down, not only are we not making money, but it's costing us money to try to figure out why, or we're not making um, the the money that we normally would be when we were up. So redundancy is the key to get rid of the single point of failure. Power issues that we can have that could lead to a single point of failure failing. A surge, which is an unexpected increase in voltage. A spike, which is a short change in voltage that could happen due to a breaker being tripped or a power outage, a lightning strike. A sag is a decrease in the amount of voltage. A brownout is when the voltage drops to a point that the lights dim or the computer shut off. They don't have enough electricity to function. A blackout is a complete loss of power, sometimes for days or weeks, more common in bigger cities. And a power supply failure is when the unit that is supplying power to the computer fails altogether and the computer cuts off completely. So, some ways that we can combat power issues. These are some things that are fairly inexpensive and make a really big difference when the time comes, but a lot of people don't implement because they just don't think about it. And really, that's what a lot of this chapter is about. It's making you think about these power issues so that when you get out in the field, you will be able to know the different ways they can be combated. So you can have a redundant power supply. So in an enterprise grade router or a server, a lot of times there will actually be two power supplies inside the device, so that if one fails, the other one can kick on and take over while you replace the one that failed. An uninterruptible power supply is another thing that will function as a surge suppressor and a battery backup. So a power strip is a surge suppressor. So the strip will catch the surge and it will probably kill it, and it probably won't kill all the other things attached to it, like your computers and your printers and your routers. But a UPS does more than that. So there's an offline UPS, which is inexpensive. Those are the ones that are $30, $40. If the primary power that it's plugged into the wall, goes down, then it will kick on the battery and switch over into a mode where like you can shut down the computer properly. It doesn't just immediately lose its power and maybe the operating system gets corrupted, or if a database was being written to, that becomes corrupted. So the offline UPS lets you turn it off. And it's charged by the main power. An online UPS is always running, so essentially you're getting good conditioned power from the line. It's your computer's always running off the battery. So if there's a dip or a sag in the voltage, it's not affected. Um, and it probably has either a serial port or a USB port where it's plugged in, and it can shut the computer down properly in the event that you're not there in front of it, like on nights and weekends. But it can only supply power for a limited amount of time, and I mean, that may even be 10 minutes, especially on a server that's requiring a lot of power. So a UPS is going to act as that battery backup And depending on how it's configured, it may let us shut down the computer properly to make sure that nothing bad happens. A backup generator is part of an emergency power system. If the electrical grid goes out for some reason, the backup generator will kick on and take over. Um, these are way more expensive, but depending on the industry, it may be a must. If you are an ISP, if you are hosting web servers, you're hosting backup information, you're somewhere like Carbonite or eFolder, you would need that. If you're a hospital, you have people who may be on life support for whatever reason, so a generator is going to be a must. There's different types of generators. There's the portable gas engine you can carry around. There's a permanently installed one that will kick up, and there's one that's a battery inverter generator as well. The gas ones tend to be what we see. The permanently installed generators are what we see generally. For redundancy of data, because we know that it's not will the hard drive fail, it's when will it fail. We need to implement RAID, especially on servers. So RAID 0 is striping. So let's say we have two 500 gigabyte hard drives. We use RAID 0, stripe the data across both of them, and we have 1 terabyte of total information. But if one of those disks fails, then all the information is gone. So it's not exactly redundancy, but it is allowing you to use 2 disks um, and get more storage. RAID 1 is mirroring, so that would be two 500 gig hard drives, and whatever changes are made on one are made to the other. If one disk fails, the other one continues to operate until we have a chance to replace the other one, and we don't lose any data. Now, of course, RAID 1 is not the end-all be-all. Fault tolerance, it's possible that both drives can fail at the same time. It's possible that your computer could get struck by lightning and everything would be gone. Um, but it is a pretty cheap implementation of redundant data on a home network. Then we have RAID 5. So it's kind of a combination of both of those. We're going to stripe the data across multiple disks, and then we're going to have a parity bit that's written to each of these disks. And if one of these disks fails, then we can put it in another hard drive and tell it to reconstruct the RAID, and most likely it will be able to. So you need several disks for this. This is also not foolproof because this has happened to me before. We had 5 disks within our server system, and 3 of them died, all within a short period of time. A lot of times, if there's a flaw in the production of hard drives, and you purchase, like on Newegg, you go and buy 5 hard drives, and they were all made about the same time in the same place. If there was some sort of flaw, they'll all die at the same time too. So you really need to get them from other sources, and that's just, a hard lesson learned on my part. RAID 6 is like RAID 5, but we're adding 2 stripes of parity information. 0, 1 is when we stripe and then we mirror, or 1, 0 is when we mirror and then we stripe. You see lots of different implementations of this in the field, and of course you've got hardware RAID that is attached to a RAID card, and you've got software RAID that's just inside the operating system, and you kind of have to choose between the two. I'm a hardware RAID gal myself. But if the hardware RAID card failed, then you would be in trouble. So RAID can't be the only thing you do to keep your data safe, but it can be one thing. You still need to implement backup, both in-house and off-site. We'll talk more about that. For redundant networking, we can have redundant network adapters, especially in a server. Very common. If one is to die, the other one kicks on. Redundant switches, in case one dies, the other one is able to pick up the load. A redundant ISP, so a lot of that depends on where you are geographically. So let's say here we would have network communications and we would also have fidelity. We pay for both every month, but if one is to go down, the other one will kick back on. In a lot of places, that's just something as simple as getting a cheap dial-up connection so you can keep running your credit card machines when the internet goes down or when the phone lines go down. You'll be able to have something else. Redundant servers, you can have what's called a failover cluster, a high availability cluster. If a secondary server takes over for a primary one, you have very limited or no downtime. Load balancing clusters is when you have a bunch of servers connected together. They share resources between CPU, RAM, hard drives as they need to, and different things can be shifted around constantly, and there's software that will do that for you. And that does happen a lot, and we don't even know it. Some more redundancy techniques. You've got a hot site, which is basically a duplicate of your organization. You can have it up and running within minutes. Computers or phones, infrastructure, and everything is installed and ready to go. A warm site has computers and phones, but you're going to have to configure things and hook things up before you can actually start working. And then a cold site is essentially a building that has, bathrooms and tables and chairs. But if for whatever reason you would have to move your infrastructure and set everything up, as you could probably guess, a hot site's going to be much more expensive to maintain. Although it's going to be quicker to get back up and running if you need to. A cold site's going to be cheaper because it's pretty much just a building, but you would have a lot of work to do to get back up to operating standards before you could get back to work. For data backup, there's three different kinds of backups you need to be able to know. A common question is they'll say, and we'll go through these in Socrative as examples, but they'll say, so-and-so backed up on this day, how many backups will they need to get back their system back up and running? Backup software can internally designate which files have already been backed up. They do that with what's called an archive bit. So the archive bit, when it's set to 0 in file properties, that means the contents haven't changed and it doesn't need to be backed up again. But if the file contents did change, the archive bit is going to be changed back to 1, and then the next time a backup comes along, it's going to change it back to 0 possibly and back that up. So a full backup is where you start with everything, and that's an absolute duplicate backup of all the files. Um, you have the differential backup, which is anything that's different, anything that's changed since the last full backup. So if you had one differential backup done and the computer failed, you would need the full backup, and then you would need the one that's everything that's different since then. The incremental backup, sometimes people get these confused. This is anything that's changed since the last full or the last incremental backup. So um, we'll go through an example of this later on, but incremental backups can kind of build on each other. Um, and there's a video available on Moodle if you want to look at that. There's some different methodologies kind of backup. One of them is a 10 tape rotation, where you have access to data that's been backed up over the last two weeks, so you don't really overwrite data until you get to the end of your set of tapes. They call them tapes. Some people still use tapes, um, but a lot of times they're using external hard drives or something as well. The grandfather, father, son is one of the more common ones. So you have a daily, a weekly, and a monthly backup that you keep on separate drives. The Towers of Hanoi, there's this little mathematics puzzle where there's three little pyramid-looking things of blocks, and you have to move it over and get them all in order from, starting from smallest on the top to largest on the bottom. And you can't take any rings off it, and it has to do. That's common in the backup scheme. Um, they use three different sets and they're rotated differently. When it comes to planning for a disaster, we call that disaster recovery planning. There's a lot of things that come into play with it. Um, a lot of it is just things that are already regulated as being part of a business, and a lot of it is things that you may not necessarily think of. You have to kind of stop and think about every possible disaster that could happen and how are you going to respond to it, which is kind of a huge task, really. So we're going to do our best and start out with a disaster recovery plan, and we're going to think about categories of disasters like fire, um, flood, long-term power loss, theft, and malicious attack that could be considered to be a disaster or maybe the loss of the building. So for fire, we need some sort of fire suppression system if a fire does break out. For flooding, we don't put our equipment in a place that's likely to be flooded, like we don't put it in the basement, and we don't put our server in the closet where we house all our janitorial supplies and our big sinks for mopping, although many people do, and y'all all know how I feel about that. Long-term power loss would be your backup generator or maybe your redundant site. Theft or malicious attack would be physical security controls like cable locking the server to the rack, keys to remove hard drives, blocking physical access to the server room, and keeping the doors locked, things like that. Loss of the building could be a gas leak, some sort of attack, if for some reason the building becomes part of a crime scene and you can't access it. Um, The server room should have your data be archived. You should have that redundant site up. It's warm enough to keep the business running if for some reason you can't access the business for, 2 weeks at a time. A good disaster recovery plan should have the policies, the procedures, and information. What are we going to do when something bad happens? Contact information is going to be who to contact. As far as employees, sometimes there's like a call tree involved where, well, I know such and such is wrong, so I'm going to call these two people under me, and they're going to call these people under them. Impact determination, evaluation of which assets were lost, what's it's going to cost to replace them, how long is that going to take. A recovery plan is determine the impact and then what steps do you need to take to get back where you can work again. Business continuity, if a disaster occurs, what's the plan to get past it? Then you could have drills or what they call tabletop exercises to try to figure that out. Copies of agreements with your ISP, the person that owns your building. Um, Having somebody on tap if there's a plumbing emergency, um, or there's um, an electrical emergency, you know who to call. And then those drills and exercises can be like these written step-by-step instructions. Here's the safety standards we're going to adhere to. There are entire businesses that it's their whole job to come in and write these disaster recovery plans. And a lot of time it's just making a best effort. And then if something bad does happen, we go back and we change the plan, and we run through it again. We do practice drills and try to figure out what's the best thing to do if something like this should happen. There's no such thing as a perfect disaster recovery plan. There's always going to be things you didn't think of, and things are going to change and morph over time, and that's natural. But what's important is to have something written down so that in the event that a disaster happens, you're just not kind of frozen in fear. Um, and I mean that's just a principle in life. If your house was to catch on fire, where does everybody meet? What are the things you take out with you? How do you make sure that um, everybody's okay? What are you going to do after that? Who's your insurance with? Things like that. That's all part of disaster recovery planning. So let's look through our chapter 15 Socrative quiz real quick. Which of the following RAID versions offers the least amount of performance degradation when a disk in the array fails? RAID 0, RAID 1, RAID 4, or RAID 5? All right, let's check out our answer here. That is RAID 1. So RAID 4 we don't really talk about. RAID 0 would definitely give the most amount of performance degradation because if we just stripe across multiple disks, if a disk fails, then we have no performance, right? Because all of our data is gone. So the correct answer would be RAID 1. Which of the following tape backup methods enables daily backups, weekly full backups, and monthly full backups? Towers of Hanoi, incremental, grandfather, father, son, or deferential? That is the grandfather, father, son. So the grandfather would be the monthly backup, the father would be the full weekly, and then the son would be the daily. You are using the following backup scheme. A full backup is made every Friday night at 6 p.m., and differential backups are made every other night at 6 p.m. Your database server fails on a Thursday afternoon at 4 p.m. How many tapes will you need to restore the database server? This is a classic Security Plus question when it comes to backups and redundancy. 1, 2, 3, or 4 tapes. So you have a full backup made Friday night at 6, and then the next Thursday you have a failure. How many tapes do you need if you used a differential backup? This is the kind of question you really need to understand the difference between a differential and an incremental backup. We need 2 tapes. So since we're using a differential backup and it's backed up everything that's different since the full backup on Friday, I need 2 tapes. I need the full backup I did on Friday, and I need the last differential backup that I did before the database server failed on Thursday afternoon. So, and I know this is a little weird because you kind of have to think, well, do they do backups on the weekends? And that can sometimes change the answer to the question. So just be sure to consider that. In this case, it doesn't really matter because they use a differential backup and they backed up everything that's changed since the last Friday night. Critical equipment should always be able to get power. What is the correct order of device that your critical equipment should draw power from? A. Generator, line conditioner, UPS battery. B. Line conditioner, UPS battery, generator. C. Generator, UPS battery, line conditioner. D. Line conditioner, generator, UPS battery. Line conditioner, UPS battery, and generator is the proper order of equipment. So depending on the UPS that you have, it might have a line conditioner built into it, which means that the power is conditioned and it's the right voltage, it's the right amps, it's the right amount all the time, and it's good clean power. You see things called saying it'll have a sine wave technology or something, and that's what that is. That will go to a battery and then the battery to the generator. So you wouldn't want to hook a computer up to just a generator, right? Um, that would be overkill if nothing else. What is the best way to test the integrity of a company's backed up data? Conduct another backup, use software to recover deleted files, review written procedures, or restore part of the backup. D. Restore part of the backup. This is an important consideration. If you have a backup that doesn't work, you have nothing. And this is a problem that I see sometimes with backup vendors that I've spoken to. I'll ask them, okay, well, you do this kind of backup, it costs this much, that sounds great. Do you ever test the backups? And they go, no, we don't do that, that's your job. And that's fine if it's my job. Then I need to be making up a schedule where I go through and restore images and try to pick data out and make sure that it's not corrupted in some way. Because if I keep just backing up data that's corrupted or data that's bad, when I actually need it, it won't be there, and then we'll be in trouble. So you want to restore part of the backup, or all of the backup if time allows, and make sure that everything is still working. Your company has a T1 connection to the internet. Which of the following can enable your network to remain operational even if a T1 fails? Redundant network adapters, RAID 5, redundant ISP, or UPS. So you know that T1 has to do with your ISP, right? So that's why you would need a redundant ISP. So maybe you have a fiber connection or a DSL connection or even just an old school phone line, whatever you need to keep yourself in business. So you would need a redundant ISP for that. Michael's company has a single web server that is connected to 3 other distribution servers. What is the greatest risk involved in this scenario? Fragile attack, single point of failure, denial of service attack, or a man-in-the-middle attack? Well, as you could probably guess from the question, they use this word, a single web server, and that lets you know that that web server is a single point of failure. So if that web server were to die, then these other 3 distribution servers can't be accessed, and that's going to lead to downtime. Which of the following uses multiple computers to share work? RAID, VPN concentrator, load balancing, or switching? As we talked about in this chapter, that would be load balancing. So they're literally balancing the load among multiple computers so that they can share the work and all the resources can be utilized kind of equally. You have been tasked with increasing the level of server fault tolerance, but you have been given no budget to perform the task. Haha, welcome to IT. Which of the following should you implement to ensure that the server's data can withstand hardware failure? Remember, you have no budget. RAID, hardware load balancing, a cold site, or Towers of Hanoi. With no budget whatsoever, if I want to increase fault tolerance on the server, I would choose RAID. So that is assuming, of course, that I have multiple hard drives to begin with because I have no budget to purchase any hard drives. But that will increase server fault tolerance because if a hard drive was to fail, the RAID would be able to kick in and possibly use a parity bits or rebuild the array. Hardware load balancing is going to require equipment. A cold site is going to require building. That costs money. And Towers of Hanoi is a backup scheme. So it doesn't exactly have to do with fault tolerance. It has to do with backup. But keeping it from failing has more to do with fault tolerance. Last question. Which of the following provides for the best application availability and can be easily expanded as an organization's demand grows? RAID 6, server virtualization, multi-CPU motherboards, or load balancing. So the best application availability and can be expanded would be load balancing. Server virtualization is not a bad answer here. Within the context of the chapter, you can kind of point out that load balancing is what they're getting to. Um, I would probably make the argument that although server virtualization can be expanded pretty well as the organization's demand grows, I don't know that it provides the best application availability because it is just another piece of hardware that has virtual servers on it, and it can still fail. And all the pieces within it can still fail, the hard drives, the memory, the board. So I don't know that it fits both of those, whereas load balancing is going to allow me to balance the workload among many different servers and probably give me the best of both of those worlds.